This is a 1-minute recording made by Scott Yost, NM8R. It's interesting because it has some man-made interference on it. It's some PLT home plug, perhaps, or something else. At least it's digital communication. This is a strong station and we cannot hear anything from the interference, but you can see it up here, or well, there is something. Here we have something. This is a strong signal with good modulation. So the spectrum here is very nice. You can see its sharp edges here and here.
Brought to you by An American Broadcasting, when your ministry has to make an impact.
Esta es WRMI, Radio Miami Internacional.
There is another station. Up here, I can click on it. And you can see it is splattering all the way out here. And if you look at the spectrum here, it's quite clear that this is over-modulated or has some kind of error on the modulating system. Well, that's not what this video is about. I have made the clear screen function make the screen gray rather than black. That means that you can see here very clearly the span that the noise floor goes over, and I can clear it by clicking here. Now, the purpose of this video is to show a little bit about interference fighting, so I go for a weak signal, let's say this one. And it's clear there are some interference here. These horizontal lines, they become very clear if I make X and then back. So you can see the clicks made this. It's about 10 to 15 decibels at this frequency here and here. There are other interferences as well, so if I wait for a while, this black zone may become a little bit bigger. So it gives the peak amplitudes over an average of 27 spectra. I will make this averaging 0, that means just a single spectrum. Then the spikes, the interference spikes, will stand out more clearly in this, let's call it memory function. You can see the peaks here where this communication link is. It goes up to about 20 dB above the noise floor. And just once more, X, B, and you can see these four made this problem. I have cut a small section of the file where this digital communication is clearly visible, and I have it in a raw file, so X, X and 1, and here we are. And I click on this weak signal, which was this one, I think. normal looking of this screen is like this. There are two ways to fight this kind of interference. This file is very short, only a few seconds, and it repeats over and over again. You can hear the few interference pulses and a few words of the voice on this station. The first way of fighting this kind of interference is to use a better AGC. I have now set the typical digital AGC with fast attack and normal hold times and release times. Attack 0 and release and hold 4. I can put a slow attack time. Let's make this 5. This means that very short pulses are regarded as interference and they are not allowed to change the AGC level. This is like an old-fashioned analog radio works, in which this kind of pulses would be clipped in the IF chain and would only affect the AGC slowly, just like they do here. I can also make the hold time 0 and the release time short, let's say 2. And as you can hear, it's much better now. We don't hear much of the clicks from the digital communication anymore. The second way to eliminate this kind of impulse interference that comes from digital communication is to use a noise blanker. So first I restore the typical digital AGC. So I put the attack time 0 and release time 4 and hold time 4. And you hear the interference has come back now. And then I press X followed by P to get to the parameter selection which you have here. And these are the standard parameters, the default parameters of Linrand. And I enable the second FFT, that's one here. And then enter to accept defaults for everything. The width of the waterfall has changed because the FFT size now is different. I will restore the previous size of the window by clicking up here in the corner. Oops, that was too much. So I go back. Like this. You can see the interference in the time domain here with something that is a group of, I can perhaps stop so we can have a fixed here. This is bursts of data, and there is another one, and there is another one. And then there are much longer bursts of data we have from here all the way here. So, well, first listen to this station. The noise blanker is disabled. I can enable it by clicking here, this yellow box. It's automatic. It's probably better to have it manual here. And I will reduce the blanker threshold a little bit. And now the interference is more or less gone, and which you can see in the time domain. There are a lot of zeroed points. But in the main spectrum, the red points are those that do not go through the blanker. And it's quite clear that a lot of signals are not red, like this one, for example, or this group. That is controlled by this red bar. So I bring it down. And you can hear there was a difference. Now that was too far because everything is red. So I go up, and about here is a reasonable place for it. Let's say like that. And now I can bring the blanker threshold a little bit below what it was before. And you can see the interference is gone. That characteristic group of 4 pulses is not there anymore, but we have other interference that the blanker cannot take care of. The one that comes just so, this one here. And I can disable the blanker, and this was successful, this one was not. So I can enable the blanker again, and now I can of course restore a better AGC. I put 5 here, and release time 2, and hold time 0. And it is possible to change the averaging that is used to determine whether a point should be red or white. I do that by the waterfall speed, make that 10 instead. Means that each waterfall line is now the average of 10 spectra, and you can see something happen to where points are red and not. So I have to change this red bar, and somewhere here is optimum. And you can see points are red where there are stations and white where there is noise. There is one more thing that one can do, and that is to use synchronous AM. It's called coherent detect in Linrad for historical reasons. It means to take this carrier, filter it through this very narrow filter here. It is about 80 times narrower than the main filter. And then use that carrier for synchronous detection and just use the in-phase component. And I do that by clicking here to mode 3. And there is a small, very small improvement. And playing with the blanket controls, that means this yellow bar, that is the threshold. If you go up high with it, the blanker is not active anymore, which you can see very clearly on the waterfall. But you don't hear much of that because the AGC takes care of most of this interference. I can make this waterfall more suitable like that. Now we should see the effect of the blanker in the baseband waterfall. So I enable the blanker again. And you can see there's only one of these interferences. There were more before. So this is with the blanker, and now without the blanker. You can see there are more things. But it's hard to hear because they don't pass through the AGC action.